My name is John Lobell. I teach architecture at Pratt Institute. This is a lecture from my course on Frank Lloyd Wright given in the spring of 2014. It addresses Frank Lloyd Wright's tall buildings. Frank Lloyd Wright's tall buildings. So let's start with the Chicago School steel frame building. The skyscraper was invented in the 1890s by William LeBaron Jenney. And one of the first ones is the Lightyear building, now the Sears building. And we have our vertical columns expressed in the facade, our horizontal floors, glass infill. There's the modern skyscraper, already done over 100 years ago. Now, the construction was steel column. Now notice this is what's called a composite column. It's made up of 4 I-beams and 3 plates. And they're all riveted together. Where have you seen those rivets? Correct. In the subway station, you see these. They could not roll very large I-beams, or we now call them wide flanges. Today they can. You can roll them 3 feet, huge ones. But they could not then. So they built them up out of the smaller pieces they could roll. So here's our column, surrounded with fireproofing. Can't have exposed metal. We then have girders. A girder is a large beam that carries other beams. Girder is the same as a beam, except it's bigger. It carries other beams. We have a girder, and we have our beams. We then span across between our beams. In the 1890s, they're doing it with construction tile. This is a material you see, like red clay sewer pipes. That's what they're using. Today, we would just put corrugated metal on here and pour 3 inches of concrete over that. That's our floor. Then you put down the rubber. Now, in that concrete, they're putting these tubes for gas, and we do the same thing. So phone wires, electrical wires, etc. Are in those tubes. So here we are, the basic principles of the skyscraper being the same in 1890 as they are today for high-rise buildings. Now, you then go to very tall buildings, and then there's ultra-tall buildings. So when you go to very tall buildings and ultra-tall buildings, when they get to be a half a mile and stuff like that, then there are other structural systems. You might have a very beefed up core, things like that. But this is a typical that we see in the Seagram building more recently. Now, they have not worked out the core. There's a column grid, and then they sort of stick on the edges, fire stairs and elevators. Later, we gather that all in a core and have open space around it. So this dominates Chicago. This is what they're building when Wright is working there. This is one of the great, most beautiful, elegant Chicago school buildings, the Reliance Building by Burnham and Root, recently renovated as a boutique hotel. And we see huge amount of glass. These bays sticking out are called Chicago windows because we're so jammed into our next to our neighboring skyscrapers that these give you a view at least up and down the street, because there's no view across the street. This is another skyscraper. And they are using terracotta for the spandrels. Today we'd be using metal. So Sullivan then develops the aesthetic of the modern skyscraper, starting with the Chicago Auditorium. Here he's trying to emulate a Renaissance palazzo, a rusticated base, a middle story, and an attic story. But he's got too many stories to do that. So, and he's working off of Richardson's Marshall Field building, warehouse, but it doesn't work. And so he then develops the aesthetic of the modern skyscraper, and it's got 5 parts, which I'll skip and do the simplified version: base, shaft, and cornice, reflecting a classical column. Now, here's our base, shaft, and cornice. We come around back. The building's in a U shape. They can't make it solid because they don't have the air conditioning or the fluorescent lights. They have electric light, but it's not fluorescent, so they can't get enough light in there. Everybody has to be at a window. Now, these are obviously, the rent on these offices is less than the rent on these offices. Now, I don't have a photograph of this courtyard originally, but today it's been painted white and glassed in, but that's not how it was originally. But if we look at this courtyard and we look at the side here, it's just plain brick. And all this base, shaft, and cornice, ends right there, is just for the front. So Frank Lloyd Wright was the chief draftsman on this building, and that's not right. The facade should not be stuck on, but should organically grow from what's inside. So my front, I'll take my clothes off, my front is different from my back, but they're in the same family because there's ribs and lungs and organs in there from the back and from the front. So there should be a family relationship between the back and front. It shouldn't be just you hang a facade onto the building. This eventually becomes the modern skyscraper. Here's the Seagram building. Now let's look at Frank Lloyd Wright. Here we are in 1896, and he does a windmill on the family land in Spring Green, Wisconsin, near where he's later going to do Taliesin. I don't have a section here, but he's got concrete here, and it comes down like a taproot. And then the structure is not columns, but folded plate. So this acts as a skin structure and gets its structural strength from the folded plates. Here he is in the 20s doing a project for an insurance building, which we won't go into, but he does use a column structure here. And now, 1951, he does the research tower at Johnson Wax. So remember, we just talked about this last week. We've got a central structural core, and we cantilever out from it. This structural central core is hollow and has in it air ducts, elevators, etc. So there's an organic analogy like the trunk of a tree. Reminds us of a Japanese pagoda. Here's our central concrete core, and then everything cantilevers out from that. And then, like a giant taproot, rooted into the ground. So a very organic analogy like a tree. Now, earlier than that, in the 1920s, Frank Lloyd Wright does St. Mark's Towers. So if you're familiar with 2nd Avenue around 9th Street is St. Mark's Church, and surrounding it was going to be a cluster of apartment buildings. And Wright got pretty far along with it, and then it didn't happen because of the Depression. And in 1952, let's back up. You remember I showed you an architect named Bruce Goff when we were looking at architects, maybe somewhat inspired by Frank Lloyd Wright, and he did these very weird houses. And he had done a rambling, huge house for Price, and he was sort of the family architect. And the Prices were an Oklahoma oil pipeline company. And they needed an office building. And so they went to Goff, and Goff said, yeah, I'd be happy to do it, but Frank Lloyd Wright never got to do his St. Mark's Skyscraper. Why don't you get Frank Lloyd Wright to do it? Which was very generous to do. They did. It was the most expensive building, most expensive skyscraper to date at the time by square footage. Extremely dense. It's not that big. So there are more expensive buildings, but bigger ones. But by square foot, it was very expensive. It's poured in place concrete. We have a series of 4 fins which spread out to hold 4 elevators, and then the space becomes the air ducts. And then we're going to span across and cantilever out from these 4 fins. Now, for that project, if someone would like to do a detailed analysis of this, they're welcome. It's really complicated. Every second floor is different, and it mixes apartments and office space in the building. So here we see the alternating floors. When we get to the top, we have Price's office. The other elevators drop off. There's only one left. Here's some of Wright's analysis. Now, here's analytical diagrams of these rotated squares. Each facade is different, dealing with the different kinds of light from, north light, east light, west light. So we have poured in place exposed concrete and then copper. So all this green stuff is patinaed copper. And since everything is cantilevered from these fins, we can be standing under here and say, wait a minute, there's a skyscraper on top of me and there's nothing holding this up. Now, the spaces are very tight. What you want in an office building is what for your space? Large, open, flexible space that you can do what you want with and change when you have to. Oh my God, we got to put a bunch of small offices in here. Or oh my God, we want one big open space. But right, there's no flexibility. It's all design. You see how tight all this is. And it's not big. So it was used for some years and then abandoned and for sale. And it has become a boutique hotel. So if you're ever near Bartlettsville, Oklahoma, this is where you want to stay. Wright designed a lot of the furniture. This is Bruce Goff. He had his office in there. Now you take that idea of that core made up of the 4 fins with the 4 elevators and rubber stamp out of that, and you just go boom, 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 boom. Let's see where we go. Here, we can make whole buildings this way. So this becomes a pattern that Wright uses in a whole series of projects. None of them were built other than the Price Tower. But they all have these fins. Here now 3 fins because we're then linking. So this becomes a series of very complex apartments. They're duplexes. There's our stair to our upstairs in our apartment. Every other floor has a slightly different geometry. And we get a bunch of, here's our taproot again. Here's another version. And then finally, in 1956, he does the Illinois, or Mile High building. Wright was having an exhibit in a Chicago hotel of his work, You got off the elevator, you looked down a long corridor, and there was a tall, thin wall. So Wright says, oh, I'll just design a building to fill in, so I'll have a rendering to fill that wall. So he declared it as a mile high, and it got it, he was, he just did it for the publicity, just a project. And it worked. So I'm a kid, and I'm watching TV, the news comes on. This is the architect, Frank Lloyd Wright, has proposed a mile-tall building, and then they interviewed an engineer. They said, will this thing stand up? And he says, sure, he's got it triangulated. It'll stand up. And Wright says it's going to have atomic-powered elevators. So here's the Empire State Building, and the Eiffel Tower, and the pyramids, and the Washington Monument. He really never worked out the elevators because it would have taken more elevators than there was space in the building. All the space would have been taken up by elevators for the amount you would need. Later, somebody worked it out. You just make express elevators and put a half a dozen elevators in the same shaft. And then, let's say you want to go to the 113th floor. So the express elevator, let's say, stops every 20 floors. So you get in, you get off on the 100th floor, and you go to a local elevator and go to the 13 more floors. Anybody ever go to the old World Trade Center? That's how it worked. You got an express elevator, you got out of what's called a sky lobby, and then you got a local elevator.